Well, hello there, and today's video is going to be a little different because, well, something happened. My tiller autopilot that I was so happy with, it broke, and I think within less than a month of using it, one of my jib sheets got hung up when I was tacking in some in some waves, but it wasn't too bad, and the boat wouldn't tack, and the the machine decided to drive all the way past the end of where it's normally able to go. There's no detection in here for when it reaches the end of its travel, and then, well, something has to give, and in this case the tiny little motor here is powerful enough that this belt got stripped out. So it's a toothed belt, and that was stripped clean, and one of these plastic cogs, or what do you call it, these little driven wheels, got stripped off as well. So there were no yeah, it was basically just spinning its wheels literally, and yeah, it didn't result in any problems because it wasn't a busy day and I wasn't in a dangerous situation. There was enough wind, and of course I can sail it without the autopilot as well, so really no problem. But yeah, it was quite shocking actually to discover that a lot of people on the internet had already also had the same problems, and some of them, it had already been solved by a lot of hobbyists in lots of different ways. And just recently, I'll link to his video. There's this guy who did a conversion by adding some micro switches in it. This is an example of the micro switches that I decided to use, because I wanted to make my own version of this. It really is a tiny little switch, and some of these bigger ones, I tried to use those first, but I really couldn't fit them easily, and so I decided to cave in and just buy some smaller ones. They have to be able to take the amps. These are 5 amps. It's marginal, to be honest. Probably be better if they were higher rated, but you seldom see these higher amperages anyway. But and this should prevent it from actually driving into that range anyway. So yeah, I'll show you what I came up with, to quote another YouTube guy that I know. I 3D printed a design that will let me mount one micro switch directly that goes over these pins, these mounting pins in here in this unit. It just sits on top, sits flush, so it will be pressed down right into position once the top gets put on, and that will allow me to mount one micro switch. Let me just get that out, right onto the body of this switch housing, and another one needs to be triggered with a tiny little rod. Now I made this out of a welding rod, which is pretty common, 3/16 stainless steel, easy to get. I think these are 1.6 millimeters. I'll put all the technical stuff in the description. I just click it on there, and it actually triggers the micro switch for me, because there's 2 reasons for this. One is there is a gyro compass. That's the most important one. Oh, it's not a gyro compass, it's a flux gate compass, which is housed in here. I can show you that if I remove this. That's the wobbly bit on the end, so to speak. Here you go. And that, I don't want to influence that by having wires which carry, let's say, 5 amps really anywhere near that thing, because it will influence the compass, and God knows it'll probably go berserk, and you never know what might happen if that happened in close quarters or somewhere near a dam or some obstacle. Yeah, so you don't want that. Keep those wires away. That's obviously what I did in the original design as well, because you see there's some digital electronics that are closer to the compass, in fact right above it for the screen, but all the power electronics are basically kept in this bottom area, and quite a distance away from the compass itself. So that's basically a great design, I think, of this board. Would have been greater if they'd actually incorporated micro switches themselves, because then they wouldn't have needed to carry the 5 amps for the motor. They could have just used them as sensor switches on one of these 2 microprocessors. They can easily, they probably have enough I/O pins that they could just have detected a couple of those switches. So yeah, they could have fixed this for about $5 worth of materials, I guess, and maybe a day's worth of engineering. But yeah, such is life. I talked to the tech from Raymarine about this, and he said, yeah, well, we've been selling these units like this for 18 years and there haven't been any significant problems. I suppose that's not significant to them, but it can be pretty significant if you're out there and you're relying on these things. So I wasn't too pleased with that reaction, to be honest. But yeah, it's fine. I didn't have time to send it in for service or replacement. To be fair, that they would have given me a good deal or replaced or whatever. I have no doubt that they stand behind these things if pressed. But in this case, I didn't want to bother with all that. I thought it was a shoddy design, and I could do better, and well, at least improve on it. Let's not get carried away here. This end stop is also a 3D printed unit. I have a previous version with not quite the right dimensions, but it looks the same. It's a replacement of the original. It has these little ears, and when the carriage here slams into the back, it breaks the original ears off. In my case, one had cracked and the other had sheared clean off. It's not a really strong design either, because you can't really see it, but this is only a millimeter of material here that it's actually holding on to. So it's not much, and my 3D printed one is not as strong as the original, which is fiber reinforced plastic. I don't know what, probably ABS, but it could have been nylon. I doubt it, because it would have been more flexible. But yeah, I'm afraid I had to print that as well. So, but I have the files for these 3D printed units, and they're open source. I'm open sourcing them. I don't care. Anyone can print them. So if you have a broken unit and you don't want to bother Raymarine with it, no problem. Just print one, or have it printed. Of course, there's many 3D printing services out there that you can use to actually just have one printed, because the tolerances are pretty close. Your printer needs to be set up, and not everyone's printer is always in a good enough condition to be able to print technical parts that need to be accurate. There's lots of things in here that actually need to be pretty accurate. Same, for instance, this switch that needs to be mounted this way. If this is slightly off, then this will damage. There's just not much play. It has just enough room to be able to actuate properly. And yeah, so if your printer is a little off, you could mess things up. So I have a well-calibrated printer here. It's a pretty good unit after a lot of work done to it. But yeah, I'll go ahead and show you the installation, and you can figure out if maybe this is something you want to do to your unit before it blows up, or when it blows up. I'm not saying if. It's, as far as I'm concerned, it's a question of when. Then maybe you can use this as a guide, and I will have the files available as long as possible, and yeah, you can go ahead and make it yourself. Right. Let's get back to mounting the switches. So this is the plastic unit that I came up with. This is printed in PETG for people who want to know. It's what the Coke bottles and stuff are made of, the plastic ones. It's quite a tough material, and crucially, it can handle relatively high temperatures compared to the usual PLA that stuff is printed in. Which might melt. Well, it probably will melt if you use it in a unit like this, because it can get hot because of its motor, the sun beating down on it. Well, you know, regular old summer sailing conditions will do it in, and this stuff is just a bit better. That's why I use it. I like printing with this stuff. It's good stuff, tough. So let's get to mounting the switches. Now first off, I've got these switches. I'll list all the part numbers down below so you can get them yourself. I have some screws that I mount them with, and I basically bought all these switches and cut the roller end off one switch. So you need 2 micro switches for this. And I also cut off this center lug because I won't be using it. And I'll be soldering to these, which is, well, against conventional wisdom, which says you should always use crimped connectors. So I cut off the center lugs of these just because there's not that much holding them on. So if you use a crimped connector and you know, spade connector and just put it on there, I didn't feel confident that that would hold for long enough. So I'm going to solder it. So it won't be plug and play. But it should be an easy enough project for most people. These are M2.5 14mm screws. I used 4 of them. They're all the same, and I've designed the parts so that you can actually use hot melt inserts to make it even easier to mount. But I'm not using hot melt inserts here because why? Doesn't matter to me. Now on the back side of this, there's holes that will fit a hex nut, and you've got to be sure to get it in there nice and straight. Usually it'll fall in by itself, so you don't need anything to stop it on the other side because the shed takes care of that for you. Right, so here's another one, and another. That's not 14, that's 10. Oh, looks like I need to get some 14mm screws. So yeah, these are the ones that I got. Hope the focus picks that up. I don't actually have a monitor, so I can't see what I'm recording. Just have to hope for the best. Yeah, that's life, isn't it? There you go. Pop that in there. It'll fall down, and we can tighten it in. Now that can be pretty tight because due to the design there's lots of reinforcement behind here. That will make sure the clicky switches towards the outside of the fat end of the design. So that's going to be the outboard side of the autopilot. Now here comes the trickier bit. There's a couple components here. You need a spring which can be taken from a ball pen. So yeah, it should be easy to source because you probably have one lying around in a drawer that doesn't work anymore, hasn't worked for 10 years. Grab that spring, throw the rest away, or risk the wrath of the significant other. Now this, I have plans for bending this with all the dimensions. It's a stainless steel rod. It's about 1.6mm. And you can just bend these things with a set of these round nose pliers. For example, on one of the prototypes, it's just a question of bending it around the round nose, and because you probably need a slightly bigger diameter, if you just move it up a bit every time you bend, you'll get a nice roughly round bend. And it doesn't have to be perfect or anything, just has to fit around this rod here. Now, mine's a bit scratched up because I've been messing with it and doing all these different prototypes, but I honestly don't care. It won't be a problem. You won't see it on the outside, so don't worry about that. Basically, it's a simple bend. One circle you bend first, then you put a 90-degree bend in it. You see it has an opening like that because there's a plastic part that it needs to clear. So it needs to sort of slide past this plastic thing like my thumb's doing now. So you can't make a full circle. I trimmed off the end of it because my circle started out almost round. A 90-degree bend is next, then the length, and another 90-degree bend, so in a parallel plane, so to say. And then it goes up just 6mm as a little catch. Now the idea is, this goes in here, then you turn it around, and you can see it hitches in there, and that allows us to actuate the switch remotely, so to speak, from here. Right, and then to take it apart, just twist it and put it in, twist it back. It's really quite simple. Then next thing is you need a spring in there. That's what this housing bit is for. And I'll explain the reasoning behind all this in a sec. Right, and you have the switch with the end cut off. Maybe yours doesn't need the end cut off. I may have gotten away without it. Put the screws in there. I like to keep them together because it's a bit difficult to hook that thing in behind with a spring inside that housing. I designed it so that you can probably, your mileage may vary, use different types of springs. This is 1 inch long, this spring, to 25 millimeters, roughly 1 inch. And I don't know, the hole is 5 millimeters wide, so I think any regular pen spring will do. I don't expect it needs to be a specific brand or model or anything very expensive, just like a big pen or, you know, one of those throwaway things. I wouldn't worry about it. And if all's well, and I didn't get a dud screw here, yeah, there she goes. That will screw in to the hexagonal hole in the back. So, like I said, you can use hot melt inserts if you want. I tested it with hot melt inserts, it works, but I decided to go with these anyway. These screws are not the 14 millimeters, these are 2 millimeters too long, but they're the only ones that I had. I designed it for 14 so that it will give a little more clearance between the bottom of the unit and the housing, so it doesn't chew its way through. So I probably need to take that down with a file a bit. Now you can see how this works. Right? This thing is actuated when the carriage just hits it, and then it stops the power, so it doesn't hit the end. And the other one is actuated when the carriage hits the end, but then it has some extra travel. That's why the spring is needed, because if it doesn't have that extra travel, the carriage hits the switch with full force, and of course that is not going to last. It is not built to take these kinds of beatings. So it's just to catch, give it a little run out before actually stopping, and without damaging anything. That's all the spring does. You can hear it clicking. Satisfying. So yeah, that's the unit basically. And I guess the next thing to do is wire it up. And for that, I'll show you the prototype that I actually used to test if everything was working. This one didn't have a spring yet or anything, just a proof of concept. This is the electronics. I'll just make them a little more visible. So what it has is these components in here. Let's see if I can show you one here. They're diodes. These are too small. I've got some beefier ones over here. These are the other ones that I'll be using. They're too big, but it was difficult to get the right ones on short notice, so I just decided to go with overkill. So you can see the great thing, what a diode does is it allows power to, I'm going to simplify this, and so don't get all pedantic on me about my explanations and what your science teacher told you, but yeah. So it allows power through in one direction and it blocks it in the other direction, right? So the thing is, if you put this on a power supply and you put the positive on this side and the negative on that side, nothing will happen. If you turn it around, you'll let out the magic smoke because it will immediately let all the power through, short circuit, melt, and it might explode in your face. So I do not suggest actually doing that. But most of us with a bit of electronics experience will have done it by accident a number of times. I hope. I'm not the only one. So what I want to do is put this diode in here. And what normally happens is when these switches are open, or unactivated. That is when the autopilot is somewhere in the middle, let's say, right, nowhere near the edges. These won't be activated, and will do basically nothing. They just short circuit these pins, these two together. So basically whatever you put in there is short circuited and does nothing. It's bypassed completely. But the moment the limit switch gets hit, they open the contacts, so there's no longer a connection between these two, and the power then depends on the direction, right? And it will only let power through in one direction, and that you have to set that up so that it will only allow the plunger to retract away from the limit, which, because if you didn't do that, it would just stop and then be unusable until you mechanically went and did something to it. Of course, you don't want to be doing that, so we put the diode in, which will allow the power through. The other switch will be shorted out, and then the plunger can return to the center position, and it will be deactivated as if nothing ever happened. But the next time it's driven to the limit, bang, again, it will stop driving, and it'll only allow you to drive or the computer basically does that, of course. It will drive the plunger away from the limit. And the same happens on the other side, except it's triggered by being hit by the carriage itself. If it hits the limit, it will stop. There's a little room for it to actually grind to a halt, and then the diode will be activated by that action, and that will only allow power through in the other direction. Notice how this one allows power from plus to minus in this direction, and this one only allows it in that direction. So both of these switches will only allow the plunger to drive the other direction towards the center, basically, and away from the extreme ends where it causes damage, especially if it's driven against the end stops with full force. And that prevents you from blowing up the mechanics of the what's it called? The tiller pilot. Yeah. This is, like I said, prototype. So it looks shoddy. I know. Alright, let's get to wiring it up. I'm going to do what I told you not to do, because I'm obstinate. I don't want that thing in the way while soldering. And I thought it would be easier to solder while the switches were being held. And like I said, I removed the center lugs, and you have to be careful if you get your own switches. It has to be the normally open connection that is cut away, because you need the common and the normally closed connection for the project, right? So if your switches happen to have contacts in a different position, I think they're standardized, but you never know, there may be 3 or more competing standards. Just make sure to check before you cut anything off. Easy to remember, the stripe on the diode goes towards the middle of this switch unit, right? They're both these stripes have to point to each other. That means that they'll be working complementary. You know? I'm going to see if I can figure out a nice way of hooking this thing up without actually making an incredible mess of everything, because it's so easy to make a mess of stuff. Maybe if I just keep that out there. This thing will be mounted quite close to the bottom, so I think it would be a good idea to mount the switch a little towards the inside here, so not right jammed under here, because then there won't be any room for it, especially since I got, what's this, like a 15 amp continuous rated diode. Is way overkill. Yours, if you get them yourself, will definitely be smaller. Well, they should be, at least. I'm gonna see how I can get that thing in there. Trying to take a practical approach here. I think that will do. All right. Now I can bend those lugs up, the legs of the diode, and I can use those to attach the cabling, the rest of the wiring, or at least the diodes on there for now. I think I'll take the same kind of approach for the other diode. Bend its legs over like that. shame I couldn't get the smaller ones. It would have been a lot easier. Try not to exert too much pressure on those switches. But yeah, that fits there snugly. So that's great. Trying to keep the pressure off the switch because the lugs might break off. I did get a couple of spares. There were, I think I bought 10 at once through Amazon. Right, now, doesn't have to look beautiful. It's just got to get the job done. That's all. And check the fit real quick. Right, you can see if it fits because these pins that it sits on should be flush with the top. Now you can see that's nowhere near fitting, so it's tight. And be honest here, it's tight. So let's see if I can get that up a bit. There. It's not going to win any prizes, is it? No, that's nice. That's flush. And the other one definitely needs a bit more room. I just got it too close to the end there. I'm going to give it a bit more room. It's not going to ever need to pass 15 amps continuous. These things can handle a lot more current for short bursts, but you have to check the documentation to see how short those bursts really can be, because they might be talking about milliseconds or nanosecond bursts. All right. There we go. New one. I'll leave it some longer, a little more space compared to the other one. There you go. Again, keep the bands pointing to each other, the bands in those diodes. There we go. Now, don't make the same mistake twice, right? Leave it some space. There is some space in the housing. There's enough space for it to actually just sit right in front here. There won't be a problem at all. So there. This way, I'll just bend those legs all the way back. There you go. Better. Yep. You have to be really careful with this connection to the flux gate compass. It's super flimsy. So if you get that stuck or pinched or whatever, it's a goner. And doesn't look like it's easy to repair. So yeah, you can see there's some room here. I'll have to make sure that these wires are kept away from here, because it's going to be that actuator wire that comes through there, and you don't want it shorted to ground, basically. You can hear it when everything's pressed in place. It just activated. This carriage just activated that switch. That's good. That's what you want to hear. Out again. Click. There it goes. So that's working in principle. Just have to remember to keep these wires well out of the way of the mechanics. So, right, like here, I'm going to take off a bit of that wire. Just keep it out of the way. Keep everything close to the switch body. Just taking off the extra lengths that are only going to get in the way. Make sure you don't cut the actual feed wires, and only cut the excess. And don't leave any bits lying around, you know, they could short out. Right, so there we have the basic unit, and I think we can start soldering it. Now it's going to need some wires. There's a feed wire from the motor, there's a connector between there, and there's another feed wire from the controller, and it's only wired into the positive of the motor. Yeah, I'll get on with it. This is great stuff. I use this AMC Raymarine from the UK. That was a bit of a issue when the Brexit happened, but it's still the best stuff I've found. It's a multi-strand wire. It's all tinned through and through, so it doesn't oxidize. Real great stuff. There you go, pre-tinned. Right, I can feel the heat traveling down that copper wire. Copper is a great conductor. There's all sorts of clamps and stuff you can also use to clamp your work if you're doing this seriously. And I'm about to join up that bottom connector between the two switches and diodes. I pre-tinned it. This time I'll use these needle nose pliers to get a good grip on there and keep some soldering tin ready. Works better with the thicker stuff. I hope it's heated up enough. Oh yeah, that looks good. Now, everything was pre-tinned, right? This makes a big difference. Freshly pre-tinned. Right. These big diodes and stuff are sucking up the heat. You know, it's basically also this wire is acting like a heat sink, and all the heat that goes into the wire is not available for the soldering. There she goes, blowing it to cool it quicker. And it looks horrible. It's not shiny, so it's usually flux. I'm just gonna get some more in there. Yeah, that'll do. Okay. Oh yeah. There's different types. Some of them need cleaning. This is not a very aggressive one. It's just like pine rosin or something. I can leave that on there. Other types need cleaning with isopropyl alcohol. Right. Cut that wire to the right length. Nope. Strip a little bit more off of it. Okay, there you go. Just bending it in shape so I can get it to mechanically force itself into contact with the other parts. I'm not saying this is the right way or anything like that, you know. It's not a soldering tutorial. It's just I'm basically just thinking out loud. Let's pre-tin it first. It's always a good idea. Get some heat to transfer and to the lug. You don't want to be just connecting the diode and not the switch. You get some real strange results, like it will only move one way. The wires have to be thick enough to handle the amperage. In this case, it's best to use the original wires as a guide. What goes to the engines, to the motor. They're thinner, which means that these are not going to be the bottleneck. A bit of soldering tin spilled there. You've got to be sure it's really connected and not just touching. But yeah, I'm satisfied. So this is the unit now. There's a connecting wire between these two diodes that are facing each other with their stripes together. And two spade connectors. One male, one female spade connector that are on there. I think these are 3mm or something. They're small. They're not the big ones that you get in your car or in the truck. So that is going to fit right in there. And with a bit of coaxing, I don't actually see that. It should sit flush because the top cover is going to come in here and it's going to press those down, and they'll be flush, and that's good. So there's no really long wires flopping around anywhere, and well, this means that we're ready for a test, I think. Now the system plugs in to the positive lead of the motor, so that goes on the little shovel spade connector. Make sure that's good and tight and insulated. So in this case it's got some shrink wrap over the top. That can stay. This bit, no, I don't like it. I want that red wire to go underneath this wire. Basically the black one too. They have this little channel that's gouged out in the original mount with the plastic. Get some dust out of there before it finds its way into the compass. Try to work clean with this thing so that no rubbish or whatever, you know, especially offcuts from leads like those diodes or anything get in the way of the compass. That would make for a seriously bad day. Alright, now again, put the red lead on the spade. There she goes. That then stays there. And the other one will plug into the PCB, the circuit board, the printed circuit board, where it has these connectors. I took a photograph of them beforehand so I'd know which one goes where. You don't want to risk it with stuff like this. You could easily blow things up. But I want to do a test first. And for that I need my power supply. Just get it. Okay. Here I am again. Well, I don't have a bench power supply. Well, I've got a sort of universal adapter that goes up to 12 volts and a couple of amps, I think 5. So it's good enough to test whether or not this thing's going to work. So let's get it hooked up. Okay. I have that wire. Best thing to do is to get that in there before the spring goes on, but if you did, like me, you can just move the spring up with a screwdriver, then insert that little click and let the spring go. So that's working. Might want to have that under the red wire in this case. There you go. Now it's not touching anything. You can see that it theoretically could short on that pin, so we're going to have to mind that, and we might have to add some insulation or anything or something. Right. So there you go. The unit sits in there nicely. Hook that out of the way for now. Check that the wires aren't pinched. It's very easy to do with these things. This is a metal plate, and they will cut through layers of insulation like a hot knife through butter if you're not careful. Alright, so there we have the negative coming from the engine, or the motor, and here the positive that I just put in here. See if I can hook it up. This is hard to hook this thing up the first time. It needs a bit of a weird angle, so I'm going to try and hook it up before actually installing it. There we go. Click it in. Put it into its pins. There you go. So you can see it pinches itself on that and doesn't want to move anywhere, which is really good. I can push it out of the way a bit of the diode and make sure it's not bending in the wrong direction, and it should move freely. So like this, that sound, that wasn't good. Yeah, I think the problem is my diode is too thick. Mindful of that little tail there. Yep. Alright. I'll have to redo that. Well, after some off-camera futzing around with it, I managed to push the diode further into the body of this unit, so it's now just out of the way, and it will allow the trigger to operate, well, with more noise than it normally should, but yeah, just leaving that last hook a little longer would have given me more clearance. But yeah, it's all good. You can see on this top end it has to clear this plastic piece, and that's all. So yeah, let's do the test. All right, so I don't have the electronics hooked up. It's just the motor and the unit that I built that I'm now testing. Right. So it's got the plus and minus, and you see the minus from the motor. So that will drive it that direction. And if you reverse the polarity, it will drive the other way. That's basically all it does. It can drive both ways. I'm going to start with a low voltage, something like 5 volts. That will allow me to see what's happening and hear if there's anything dangerous going on here. But no, it sounds really good. Not a problem. So let's up the volts. The max I can give it here is 12.8. In reality, I think it's something like 13 volts that it's giving off now. It's a little less than a fully charged battery might give, which has some consequences I'll explain later. And as you can see, the switch was actuated and it stopped short of bashing into the end here. It still has 3 millimeters over. I'm leaving those 3 millimeters play in there because a well-charged battery might have more than 13 volts, and it will, as a consequence, drive on just a little further because of its mechanical momentum. Now turning this around, so reversing the polarity, I've got minus on minus to the motor, plus on plus, will allow me to drive it back. And reversing it again, the switch is activated and it stops. So yeah, no problem there at all. Let's drive it all the way into the other side. Oops, see, I want to clear the wiring. And again, a few millimeters left on the end, just to compensate for any for a battery that might be charged at 14.7 volts or something. Now you can see it won't do anything anymore in this direction, but if I reverse the polarity, it will allow it to drive back into the middle and back again. Boom, and it stops without destroying any teeth or wheels or whatever other mechanical parts like this end stop here. So yeah, that's the project. Basically all that's left now is to hook it back up and well, actually hook the PCB up and close the board. Right, so I thought I'd promise you guys a time lapse, but the pictures of the wires and the colors and that go to the to which connectors they all went. That's on my phone, and my phone is what I'm using to record this. And right at the moment, it's duct taped to a microphone standard. All right, microphone stand, so I can't really do a time lapse from the beginning. But I connected the compass wire. I connected all these in the right order and made sure they were seated firmly right up as far as they will go, and that everything can run clear. I didn't need any hot melt glue in the bottom because the wires were able to be routed through this channel right here, and that will be pressed down on by some tabs in the top cover, and that will keep everything really firmly in place, and it's all going to be really snug, and I'm absolutely not worried about anything contacting anything. The wires here are sorted as well, it won't contact the pins. Yeah, it'll just be activated. Yeah, I double checked everything, so I'm going to just now start screwing things back together. Oh yeah, by the way, here you can see the stripped out cogs and the belt. As you can see, I'll turn it inside out so you can see it works fine, but then boom, it's yeah, completely stripped off the teeth on that point. Such a shame. Nothing hung up, no rubbish in there. Careful not to damage the seal. This is still a very new unit. If we're a bit older, I would, for example, add a little bit of silicone grease in there to help seal it. I like to use silicone on these plastic and rubber type things because it won't destroy the rubber. Alright, so there we go. I see there's some dust on the display. I cleaned out all the bits that came out of the rubber wheels and the plastic wheels and the rubber bands, the drive belts, so that they wouldn't foul up the compass or any other parts. Just noticed there's some, you don't want any fingerprints and stuff to remind you of your repair for years after. Trust me, been there, done that. Greasy fingerprints on the inside of the display. And then these should mate up nicely. And taking double care not to destroy the seal or pinch anything here. There you go. Yeah, you can see it seals nicely. I don't have to exert a lot of pressure in the area of the repair. These screws are slightly smaller. Just feel for the start. There you go. So I don't damage the threads. It's such a shame. Beautiful units. 3D printing rubbish. So go to start. There she goes. Torque them down properly once I'm done. They're all the same length. Great stuff, Raymarine. They've done almost everything well, just not quite, which is such a shame. It's starting to look like a usable piece of gear again. There we go. last two. Already done that. It's done. There you go. Now that thing tighten up. And that is always check the spare parts if you didn't miss any parts. Oh my, no, that one was okay. No, yeah, that's it. Oh, one more look. These are the hot melt inserts that you can also use optionally. I don't think you guys can see that. One more thing. Hot melt inserts look like this when they're melted in, and you can just screw them in. They don't require washers or nuts on the other end, but yeah, this it'll both work. Yeah, well, thanks for watching, and well, like and subscribe if you want to see more of my adventures, and I'll put all the relevant information that you need to make one yourself in the description, and yeah, good luck and happy sailing.